All right, guys, here we go. Notes for right triangles and trig, hashtag rewind. So why did I call this hashtag rewind? I could have actually called this notes 3.75 or something. Anytime you see a decimal in the notes like 3.5, 3.75, those are not like real notes. They're just like, like stuff to catch you guys up on. And so this one here is kind of stuff we already know, but we're just bringing it back just to reiterate because we're going to be having a test pretty soon, probably next week, if you want to put that on your calendars. Probably next Wednesday, but we'll see. It all depends on how much we get done Wednesday and this Friday. All right, so in a 45, 45, 90 triangle, you have this property n square root of 2. You guys remember that? So the leg, you're going to say n, and the hypotenuse, you're going to say n squared root of 2. So n squared root of 2. Remember that the hypotenuse is only properties of a right triangle. If it's not a right triangle, then you don't have a hypotenuse. You just have legs or sides. It just depends on what textbook you see. All right, so here it is. I have a side here that's 8. This is a 45, 45, 90 triangle because you have a right angle here and you have 45 there. So remember, all three angles sum up to 180 degrees. So that x has to be 8 as well. And that y, all you got to do, according to this, it says that you just multiply the hypotenuse by square root of 2. So this y has to be 8 square root of 2. So x is 8, y is 8 square root of 2. And that's it. Does that make sense, guys? Okay, cool. This one here, this leg is 25. That means this leg is also 25. So that means the hypotenuse here is 25 root 2. So under x, you're going to write 25 root 2. And under y, you're going to write 25. And I think that's it. There's nothing crazy going on there. How do we feel? Do you feel okay? Okay. All right, on number 3, I see that this time the hypotenuse is 19. So I'm going to go ahead and do 45, 45, 90. Yeah, let me close the door. Does someone want to walk over there and close that door for... Thank you, miss. All right. That 19 is the hypotenuse. You're going to write 19 underneath that n squared root of 2. So that means you can write n root 2 equals 19. And then to get n by itself, you're just going to do what? Yeah, divide by root 2 or square root 2, however you say it. So n equals 19 over root 2. And then we want to rationalize this. So when you rationalize something, when you rationalize a fraction, you're going to multiply by square root of 2 over square root of 2, or in this case, by square root of 2 over square root of 2. That just means you don't want to have a radical in the denominator. So you're going to have x and y as 19 root 2 over 2. So that's what the answer is. It does not reduce. See? 19 root 2 over 2. How do we feel, guys? Nothing crazy, right? 30, 60, 90 triangle. You always want to reference your short leg. So the short leg, you're going to write n. And then the 60 degree, you're going to write n root 3. And then the 90 degree, you're going to write twice n. So this is n. Wherever the 30 degree aims at, the opposite side, that's n. And then wherever the 60 degree aims at, that's n root 3. And then the hypotenuse, 2n. Are we still okay? Nothing crazy. Short leg is n. Longer leg is n root 3 or n square root 3. And the hypotenuse is 2n. We're ready? So this right here is 30 degrees. That 30 degrees is aiming at that 5. So if you want to do the 30, 60, 90 to use this as a reference, n root 3, and 2n. So then across that 30 degrees, that's 5. So then that means this is my long leg, the x. So that means that has to be 5 root 3. See? And then y is my hypotenuse, and we just double the 5, which is 10. So put a 10 on the y, and then put a 5 square root 3 on the x. And that's it. Pretty straightforward, guys. All right. Again, right here, that 14 is opposite, so that's your short leg. So that means this is 60 degrees up here. So that y has to be your long leg. So then that means that y is 14 root 3. Does everyone know where I got the 14 root 3 from? Okay. And then the x is double the short leg. So I'm going to double the 14, which is, there you go. Seems like you guys are pros at this. I'm going to take out my little gun here. I'll do it on this little notepad. Sorry, guys. It lost its flavor. All right. Next one. This time the 32 is the hypotenuse. The x is the short leg. So what is half of 32?
16.
So that's what x is. And then I take that 16 and I multiply it by. So there it is. If they ever tell you to round it, then just take your calculator, go 16 times square root of 3, and whatever that number is, then go from there and round it. All right. All right. So here we go. This is still a review. Nothing in here is brand new yet. It says I'm going to write not to scale. And it says in triangle VWX, the measure of angle X is 90 degrees. Okay, so that one, make sure that angle X is 90 degrees. So here's X. And then it says VX is 21. So it doesn't matter where you put the V and the W now. So VW. So VX is 21. So I'm going to write 21. WV is 29. WV 29. And XW is 20. XW 20. What ratio represents cosine of W? So here's W. So SOHCAHTOA. And it does say ratio. It does say ratio. So we're just going to go cosine of theta. You can also say W there if you want, but I already wrote theta in there. Cosine is adjacent over hypotenuse. So what do I write? Perfect. And that's it. Leave it alone. It does not reduce. Next one, it says, find the length of side x in simplest radical form with a rational denominator. There's two ways we can do this. I would probably, let's see, what's the easiest? It's a 45, 45, 90 triangle, guys. So I think I would probably go n square root of 2. So if that's square root of 3, this is square root of 3. And then, well, they don't want that. They want that hypotenuse. So I take this right here, that x is n square root of 2. And remember, that was n right there. So I'm going to go square root of 3 times square root of 2. And then law of exponents, they both have square roots. So what's 3 times 2? So just write square root of 6. And that's it. So that's what x is. X equals square root of 6. How are we feeling, guys? Okay. Is it okay if we go to the next one? Okay. 30, 60, 90 triangle. That's what I'm going to write right here. 30, 60, 90 triangle. N root 3, 2n. That's 60 degrees. So that square root of 2 is opposite that 60 degrees. So I'm going to write the square root of 2 right underneath the n square root of 3. So that means n root 3 equals root 2. I'm going to find my short leg by dividing by root 3. And here it is. N equals root 2 over root 3. And you can, if you want, write 2/3 inside the square root. But I'm going to leave it like that. And then I'm going to go ahead and double it. So I'm going to write n equals square root of 2 over square root of 3. And then so that 2n is going to be 2 square root of 2 over square root of 3. And if I don't tell you anything, you can leave it like that. But it does say rational denominator. So that means no square root in the bottom. So I take this answer, the 2 square root of 2 over square root of 3, and I'm going to multiply it by square root of 3 over square root of 3. Are we okay so far, guys? So I'm going to have 2 square root of 6 over 3. And there it is. Nothing reduces. So that's my answer. That's what x is. Is anyone confused, or are we okay? Yeah. Here we go. It says triangle QRS. The measure, again, all these are not to scale. Not to scale. And I know it's a little warm in here and you guys just ate, so this is not the most exciting thing to do after all that, but that's okay. In triangle QRS, the measure of angle S is 90. So here's angle S. Here's angle Q, or vertice Q, and then here's vertice R. Angle Q is 61 degrees. So I'm going to write 61 degrees. And then QR is 79. So QR is 79 feet. Find the length of RS. So I'm going to write X here. All right. So again, SOHCAHTOA. With respect to 61 degrees, is that X opposite, adjacent, or hypotenuse? Opposite. What about the 79? So which one uses opposite and hypotenuse? So you're going to write sine of 61 degrees equals X over 79. And then how do I get X by itself? Times 79 times 79. So here it is. So I have X equals 79 sine of 61 degrees. I'm going to take my calculator, make sure that I'm in what mode? degrees. Do you guys want to use NumWorks or do you guys want to use Desmos? Desmos? You guys don't like NumWorks? Yeah, I like the NumWorks calculator also. I honestly, if I could, I would use it online. I like the NumWorks calculator if I can't use the TI-84. But it doesn't matter. You can use Desmos as well. They're all good, guys. They're just tools. The Desmos, the SAT. Maybe you want to use Desmos because the SAT has it, and so does the AP exam. So that's fine. 79 sine 61. So here we go. I'm gonna go 79 sine 61, and I get an answer. But I look at that answer. Could I? Is it possible for me to get a negative distance? No, not right now. So obviously something's up. Click on the little wrench and then click on degrees, and then there it is, 69.09. And I think we already did this question in the previous notes. Like I think it was the exact one because I remember just copying and pasting it. X equals 69 feet because it says nearest feet. There it is. Okay, side note. Okay, go to the top of this margin on the next page. What if I have a triangle? And let's see. I'm gonna make up this angle. Let's make it. No, we can make it the same degree, 61 degrees. And up. So this time I'm gonna put X here, and I'm gonna put 79 here. Not to scale. So I have this angle, and I'm trying to solve for X. So it's another example because I noticed that I didn't put one of these in there. So if I want to solve for X, SOHCAHTOA, which one uses 79 and X? Well, with respect to 61 degrees, is that 79 opposite, adjacent, or hypotenuse? What about that X? Which one uses opposite and hypotenuse? So I'm going to write sine of 61 degrees equals 79 over X. Relax, you're doing it correctly, but this time the X is in the bottom. Do you guys notice that? I'm trying to solve for X, so I can't solve for X with X in the bottom here. So I'm going to multiply the right side by X. Whatever you do to one side, you do to the other. So now I have this. I have X sine 61 equals 79. And then how do I get X by itself? Yeah, divide that sucker by sine 61. Sine 61. Sine 61. So there it is. So X equals 79 divided by sine 61 degrees. So let me see what that is. I take my little calculator and I go, I already forgot. Was it 79? 79 divided by sine 61. Are those the numbers we used? 90.325. 90.325. There it is. Okay, how are we doing, guys? Yes.
Is it like if it doesn't say in the question, which like it usually does, like round to the nearest whatever?
Oh yeah, if it doesn't say, give me 3 digits after the decimal. Delta Math is going to tell you all the time, but if I give you an exam, 3 digits after the decimal, always, always, always. Okay. I know, guys. I know you guys are sleepy, especially if this room's a little warm. This is why I want standing desk. If you have standing desks, it's harder to fall asleep. You know? So if you feel like you're getting tired, just get up. Go drink some water. Go do something. I would offer you one of these, but I don't think I can. So sorry, guys. All right, let me take a sip. It tastes okay, I guess. All right. Here's the question that we skipped, but we're going to do it now. It says, by the way, has anyone ever gone on this interstate in California? Oh, okay. Interstate 5 in California, I haven't. I've never even been to California. So Interstate 5 in California enters San Joaquin Valley through a mountain pass called the Grapevine. The road descends from an elevation of 3,500 feet above sea level to 700 feet above sea level in a slant distance of 5.5. So it's not a nice linear distance, but that's fine. It's approximately, right? Approximately what angle does the roadway make with the horizontal? Okay, so here's my horizontal. And I'm going to draw a right triangle. And I'm going to say that at this type, way over here, I am 3,500 feet above sea level. And then when I'm way down here, this is my right angle, I'm only 700 feet above sea level. And here's the angle that I want. It says what angle does it make with the horizontal, so there it is. And this distance here is 5.5 miles. Are we still okay? All right. So before I get started, I need to know what this vertical displacement is. Have you guys already used that word in physics? Okay. Displacement. So I want the vertical displacement. Maybe context clues makes you guys already know what that is. When you say vertical displacement, I mean like net distance. That's 3,500 up there. That's 700 feet right there. So if I want to figure out the net distance, I'm just going to subtract 700 from 3,500. Does that make sense? Okay, so when I do that, let's see. I got to go in pieces. So I'm going to subtract 5, so I'm at 3, and then I'm going to subtract 3, so that's 27. So then let me know. I make mistakes all the time. Is that 2,700 feet? No, 28. You see, I didn't do it on purpose, guys. 7, 8, 9. Yep, you're right. No, wait. 5, 6, 7. Yes, 28. I don't know. Sorry, I said 6, 7 too as well. All right, yeah, it's 2,800. It's 2,800. See, it's been a long day, guys. So there it is, 2,800 feet. And then before you can do it, I need to transfer that 5.5 miles to feet. How many feet are in a mile? Okay. They're being nice. If they wouldn't have given us how many feet are in a mile, would you have been able to do this question? No. So you've never memorized the 5,280? Have you guys ever seen the movie Remember the Titans? No? Do you guys know what I'm talking about? It's a football movie. And the coach, I already forgot his name, but there's a running back. His name is Petey, and he drops the football, and he grabs the football. And this is how I learned it. I was in high school. I'm giving away my age like that, but it's fine. Yeah. So the coach takes the football, and he's like, "You take this ball and you run." And he's like, "Oh no!" First he goes like this. He has his helmet. He hits his phone. How many feet are in a mile? Don't worry, I'm not gonna hit you. I don't want to come out on Channel 5 News. How many feet are in a mile? How many feet are in a mile? And he's like, I don't know. He's like, 5,280 feet. And you run every single one of them, Petey. And then he takes it and he runs 5,280 feet. Anyways, that's how I memorized how many feet are in a mile from that one movie. I memorized a whole bunch of random facts from movies. How long did it take for the sun to reach Earth? I mean, it varies, but on average, 7 minutes or 8 minutes. And I got that from what's that movie that Aerosmith sings? Yeah, they were like, oh yeah, it takes about 8 minutes for the sun to reach. Okay, I'll stop. Should I leave all that info in here that I'm recording? I'm just going off on tangent. Hey YouTube, don't give me a thumbs down if you came for some info. Hopefully you're getting more than just math. All right, here we go. 5.5 miles. And what is this called? Stoichiometry. When they do this, in 1 mile, there's 5,280 feet. By the way, stoichiometry is for a chemistry term. That's just called dimensional analysis. In 1 mile, there's 5,280 feet. Do you have to do that? No, of course not. Just take the 5.5 and multiply by 5,280. So here we go. I'm going to take my calculator, and I'm going to go 5.5 times 5,280. 29,040. So this is 29,040 feet. Okay, now we're ready. With respect to that angle, is the 2,800 opposite, adjacent, or hypotenuse? What about the 29,040? What uses opposite and hypotenuse? So I'm going to write sine of theta is equal to 2,800 divided by 29,040. The units have to match, guys. You can't say 5.5. The units have to match. Now, I want theta by itself, so I want to get rid of that sign. It's always sign of something. So I have to get rid of that sign. It starts with the letter I. Inverse. You can also say arc in case you were like, I thought it started with letter A. Whichever one. So I'm going to do inverse sine. That's how you get the theta by itself. So here we go. I'm going to put an arrow. I'm going to write inverse sine. Okay. I'm going to write theta because that's one that's on the left-hand side. Theta equals inverse sine of 2,800 over 29,040. Are we okay with that? Hit me, miss, hit me.
No, we got it.
For sure. Oh, show. Is that a yeah? Okay. Yes? Okay. Here we go. Where's the inverse sine? I don't see it. Click on functions and it's right there. And then it needs to have something. So what do I put on the inside? 2,800 divided by 2940. 5.5329. I guess truncated is 5.5329. Did it tell me how many degrees? To what? Nope. 5.5. I already forgot. 5329. 5329. Put a little degree symbol. If you don't put a degree symbol, it's a what? Radian. So put a degree symbol. What's up, Taylor?
Wait, so how did you know how did you know how to put inverse? Or like, why did you put inverse?
Well, I don't want sine. I want theta by itself. In order to get theta by itself, I gotta take the inverse of it to get theta. I'll give you a cop out. It's not the best solution, but I'll give you a cop out. So what's a cop out? That means it's not really formal. So don't write this down. Just listen. So if I tell you 5x equals 15, and I want to get x by itself, yeah, don't write this down. Just listen.
Oh no, I'm writing the other.
So what if I told you you can't divide? What is like you can't divide? Like I don't want you can't divide. Obviously I know divide by 5, divide by 5. But I'm telling you can't divide. Don't I see this? How else do I get the x by itself? Well, I'll take the inverse of 5, and I know inverse for numbers is the same thing as reciprocals. So I'm gonna go times 5 to the negative 1 times 5 to the negative 1, and it's not the same. It's not the same, but they're related. So x equals, now look, if I go 15, if I take my little thing here, and I say Miss Wimberly, and I go 15 times 5 to the power negative 1, look at that. I got my same thing. So it's kind of like that, but not exactly. That's a cop out. So if I want to get the theta by itself, I got to do the inverse sign. And the inverse sign, this is a function, that's a number, so it's not really the same thing, but it's the same concept. So inverse sign gives you my theta by itself, and I just do inverse sign of whatever I have right here. And that's what gives you the theta. What's up, Miss Wimberly?
What would you put 300 after the decimal for the
300? I don't remember putting 300.
or 4 digits after the decimal?
Oh, I'm just used to. Oh, got it. I'm used to just writing a whole bunch of digits after the decimal because of calculus. For accuracy, pre-cal and cal, put 3 digits after the decimal always, unless they tell you otherwise. You know what I mean? So yeah, keep hitting me. Did I answer all your questions? Did I answer your question, Miss? Okay. Is everyone okay so far?
Yes.
Okay. Let's go to the next one. It says in triangle PQR, the measure of angle R, so not to scale. Here is angle R, and then P and Q. It doesn't matter where. And then say QR is 8, so QR is 8 feet. And RP is 3.9. RP, 3.9 feet. Find the measure of angle P. All right, here's angle P. And yeah, I'm going to have to use trig. Here's angle P. With respect to that angle, is the 8 opposite, adjacent, or hypotenuse? What about the 3.9? So which one uses opposite and adjacent? So I'm going to write tan of this theta equals opposite 8 over 3.9. And then, all right, Miss Taylor, no pressure. What do I got to do to get rid of that 10? What do I got to do to get theta by itself? Well, okay, be careful. Don't say tan and then do the inverse because that's going to cancel each other out. Do negative 1. Okay, that means inverse tan. Yes, so what you're saying is this. You say theta equals, so what you're going to say is inverse tan. You can also say arctan. Inverse tan, that's tan to the negative 1, that's inverse. And then you write 8 over 3.9. Cool or not cool? Cool. Yeah, don't be a robot, miss. So here we go. I'm going to take my little calculator, and I'm going to go inverse tan. Where are you, inverse tan? And I already forgot. Was it 8 divided by, was it 3.9?
Yes.
3.9. 64. Did it say how to round it? Nearest degree. So we're going to say 64 degrees. 64 degrees. Ask me, guys. Ask me. Leave it. Oh, okay. All right. Triangle NUP. Triangle NUP. So here we go. Not to scale again. Not to scale. My right angle is at angle P. And then it says no is 55. So no. 55 feet. And then it says my OP is 22. Find measure of angle O. So here's angle O. So the nearest tenth of a degree. So that's 1 digit after the decimal. All right. So SOHCAHTOA, with respect to that angle, is the 22 opposite, adjacent, or hypotenuse? What about the 55? Which one am I going to use? Cosine of that angle equals 22 over 55. All right, fam. What do you think I'm going to do, fam? How do I get theta by itself?
Yeah, use the inverse.
That's right. Inverse of what? There you go. Do inverse of cosine and see what that is. So I take my calculator. Make sure your calculator's in what mode? Degree. Inverse cosine. Was it 22 over 55? So 66.4. Put a little degree symbol. Do you guys know what the word truncated means? Did we already talk about that? No? All right. What if I needed to go to 3 digits after the decimal, a thousandths place? So let me just write this as what if. So this is what I want you guys to tell winners next time. So what if thousandths? I can't even spell. Thousandths place. All right, whatever. THOUSANDDTH, thousandths. All right, so 66.4, and let's see, 66.4218. Let me just write that. I know that's not thousandths. 4218. Okay, so here it is. The first 3 digits is the thousandths. And so I can either say 66.421. This is called truncated. Or 66.422. That one you know. That one's called what? Rounded. And then degree symbol, degree symbol. So when Winters does his physics, and he's like, give me 3 digits after the decimal, raise your hand and be like, do you want the answer truncated or do you want it rounded? Because in math, you do it truncated. It doesn't matter. I prefer truncated in calculus, but really it's because I write a whole bunch of digits, like 5, 6, 7 of them. All right, let's keep going. I noticed in first period when I was doing these notes that I gave you delta math, but I didn't give you any of these. So maybe the next time I'll probably put some of those in there, but it might not go with that lesson. It's just that I'm behind on that a little bit. It says, suppose that theta is an acute angle of a right triangle and that tan is 2 squared root of 3 over 5. It says find sine and cosine. So here it is. Here it is, not to scale, just some random triangle. And here's that angle. And remember that tangent is opposite over adjacent. So that's like OPP, and this is like ADJ. So opposite to this angle, 2 squared root of 3, and the adjacent, 5. So in order to find sine theta and cosine theta, recognize that we got to do Pythagorean theorem. We got to do Pythagorean theorem to find the hypotenuse. So on the side, I'm just going to go, let's see, what do I call this? X. 2 square root of 3 squared plus 5 squared equals x squared. And then when you don't need a calculator. Well, you might. We'll see if this number is like a weird one. So let's see. 2 times 2 is 4, and then square root of 3 times square root of 3 is 3, and then 4 times 3 is 12. You see how we did that, guys? And then that 5 there squared is 25. And yeah, try to do as much as you can without a calculator, guys, so you can be like fluency. 25 plus 12, 25, 35, 37. And yeah, that's not going to be a perfect square root. So x equals square root of 37. Leave it alone. Yeah. See how this is squared? When you take algebra, I don't know, I'm just going to do something like this. And they square it. That's the same thing as saying a to the 6 b squared. So I just did like this one here squared. So 2 squared, and then I did square root of 3 squared, like that. And so then what's 2 squared? 4. And then the square root of 3 squared cancels out, so it's just 3. So I got the 12. Remember that square root also means x to the, like, as an exponent, like to the half. So if you want, you can write like half there, and then half times 2 is just 1, so there it is, 3 to the power 1. Like however you see it, it doesn't matter how you do it, like you'll get it right. Like you can go from so many different angles. And then I just added those two, and then I took a square root of that sucker. That makes sense? Okay. All right. We haven't answered the question yet. Does it ask me to rationalize it? It does not. So if you want, on this one and this one alone, you could write this as 2 square root of 3 over square root of 37. And then cosine of that angle is adjacent over hypotenuse, so 5 over square root of 37. Now, if you don't like it, by the way, I'll slow down. It's not asking me to rationalize it. Does it ask me to rationalize it? You can leave it alone right there. You can. But if it bothers you, I mean, I don't know, does it bother you? If it bothers you, we can continue. All right, let's continue just in case, just in case. So I'm going to multiply this by square root of 37 over square root of 37. Now, I make mistakes all the time, as you saw earlier. Let's see what this is. I'm going to say sine theta equals, okay, I'm going to do 30 times 3, which is 90, and then I'm going to add 21. So what's that? 91, 111? So 2 square root of 111 over 37. And I make mistakes all the time, guys, so you guys check me. I just did it in pieces. 37 plus 37 plus 37. So I did 30 plus 30 plus 30, and then I added 21.
So if it doesn't tell you to rationalize the denominator,
Yeah, you don't have to do it.
have to do it?
Nope.
Okay.
I'm just doing it just to make sure that we know how to do it. You know what I mean? 5 square root of 37 over 37. So let me circle this one and that one. You don't have to do it. You don't have to do it if it doesn't tell you. But do you think UH is going to have it like this? You think UH is going to have that answer? No, they're not going to have that answer. They're going to have 2 over 37 with the square root of 111 on the side. All right, do you guys remember what secant was? Secant was the reciprocal of which one? No, not sine. Cosine. It's all good. This is a safe space. Remember, it starts with an S, so the original started with a C. The first letter toggles. So let me draw a triangle. So here's my angle. Here's my angle right here. And so that means that cosine was 7 over 13. So I'm going to write 7 right here, 13 right there. Does everyone know why I wrote the 7 where it is and the 13 where it is? Okay. I need to figure out what this leg is right here. So I'm gonna call that x. So I'm gonna go 7 squared plus x squared equals 13 squared. So we're gonna go 49 plus x squared equals 144, 169. I want to say it's 169.
Yes.
And then I'm gonna go x squared equals 169 minus 49. Let's see, 170 minus 150, 120. Yeah. And now I'm gonna take a square root. Bam, bam, chop. I don't know how to do that one. Well, 3 times 4 is 12. So 3, or let's see, 30 times 4. And then 30 doesn't break down. 6 times 5. What's the square root of 4? So this one is 2 square root of 30. Now we are ready. They want cosecant theta. Cosecants are reciprocal of sine, so I'm going to write sine first. Sine theta is 2 square root of 30 over 13. So cosecant is 13 over 2 square root of 30. In a little bit, we'll fix it unless they... okay, we don't have to. We can leave it alone right there. And then tan... Don't worry, we're almost done. We're almost done. Is opposite over hypotenuse. I mean, opposite over adjacent. So I'm going to write 2 square root of 30 over 7. Are we okay, guys? Okay. How are you doing? Are we kind of tired today, guys?
No.
Well, I'm tired. Every Sunday, almost like clockwork. Not every Sunday. I wasn't able to yesterday, but almost every Sunday, it's almost religious. I take a nap right at noon. Like no matter what. There'll be some Sundays that I wake up just to eat breakfast and I'll go right back to sleep. I don't know why. And it's only Sundays and no other day do I do that. But for whatever reason on Sundays, that's just the way it is. I don't know. Do you guys know? Are you guys biology experts? Why I do that on Sundays and only Sundays? what is it called? Trained behavior? Is it trained behavior? Did I just train myself to just do that every Sunday, no matter what? It's called what? Oh, but every Sunday I do it. No matter what. Every Sunday I do it. I do that all the time. Self conditioned. Ooh, usually like 2 hours.
Every night?
No. I thought you guys were talking about my nap. My nap, 2 hours. So I go to sleep at noon and wake up at 2.
Well, a nap should be an hour.
I can't do that.
A full sleep cycle. 30 minutes is your
Okay, sorry guys, sorry. I took you guys off on a tangent. Maybe I'll delete that from here. All right, here we go. When I want to go from radians to degrees, what do I got to do? Yeah. 180 over pi. The pi's cancel out. And this one's going to turn to, I believe that one is 210 degrees. Cool or not cool? 3 pi over 2. Multiply this by 180 over pi. The pi's cancel out. And this one's going to turn to 270 degrees. This one right here, multiply by 180 over pi. The pi's cancel out again. And I believe this one turns to 165. Now, don't quote me. Go ahead and do the math and make sure that we're right here on this one. Are we okay so far? All right, here we go. Go to the next page. Side quest, just a little bit on the UH quiz. What it means to find arc length. Okay, the circumference of a circle is 2 pi r. We already know that from the days that we've been talking about. So circumference of a circle is 2 pi r. Arc length is this in blue. And if I tell you a central angle, Chav, what's a central angle? That angle there is described as a central angle because it's in the center of your circle. So because it's in the center of your circle, we call that a central angle. Cool or not cool? Cool. So I'm going to use the letter S. That's the letter that they usually look for arc length. So let me put here arc length. So that arc length is like a percent I guess let me go ahead and say. That's like the arc length is like a percentage of your circumference. What's up? In this case, but I don't have to be like that. I can be like this. Oh, okay. Like that. Yeah, the way I made it look like 90 degrees. But it can be any angle, guys. So S equals theta over how many degrees in a full revolution? 360 times 2 pi r. This is if degrees. If degrees. Nothing cancels out, see? But if in radians, and I'll do that one in circles, in red, S equals theta over how many radians in one revolution? 2 pi times the circumference of a circle, 2 pi r. Notice that the 2 pi's cancel out, and you just get theta r. Look how cool that is. So that's why sometimes radians is superior to degrees. It simplifies things a lot easier. If radians. And I don't want you guys to be a robot. This right here, theta over 360, that's like a percentage. That theta over 2 pi, that's like a percentage. And of course, the 2 pi's cancel out and you just get theta r. Cool or not cool? Cool. All right. Area of a circle. Do you guys remember area of a circle? Start with a pi. Pi r squared. So pi r squared is area of a circle. But if I wanted this area, notice that I'm shading it in. Obviously it looks like 1/4 of a circle, right? So 90 over 360 will be 1/4. But we don't know that angle. It could be any number. So I'm going to write area of a circle, but I'm going to put sector, is theta over 360 times pi r squared. Again, this theta over 360 is like a percentage. Like a percentage. If you're in radians, circle sector. Then this becomes theta over 2 pi times pi r squared. Notice that the pi's are going to cancel out. And you just get theta r squared over 2. Isn't that cool that it simplifies to that?
Wait, what's the first one for? Degree?
Oh, yeah, this one here is in degrees.
Okay.
If degrees. And then this one here is radians. Okay, I think we covered everything, guys. I think we are good. I think. Do y'all feel okay? Okay. All right, here we go. Find the arc length when theta is 240 and r is 6 centimeters. So I'll give you a visual. So here is 240 degrees. Let's see. 240 is like right there. So they want this distance in blue. They want that. So you go S equals 240 over 360. If you want to put the degree symbols on, then you can. Times 2 times pi times 6. You take your calculator. I mean, some of you can already see what percentage that is, but if you don't see it, that's okay. So you go 240 over 360. And there it is, it's 2/3. And I'm going to multiply by, let's see, by 12. I'm going to leave it in terms of pi. So I'm going to go times 12. Oops, I put 2 little dots. So there it is, 8. And I come back and I write 8 pi, and I need units, centimeters. And there it is, guys, 8 pi centimeters. Are we okay so far, guys? Is it making sense? Okay, let's go to the next one. And I don't know why I made the margin so big, so my apologies, guys. Next time I'll fix it. It says find the arc length when theta equals pi over 4 and r is 9. Now look how simple this is. S equals theta r. So S equals pi over 4 times 9. So 9 pi over 4. Don't be a robot. We know where this is coming from. Remember that this came from here. Remember this came from right here, guys. So don't be a robot. I don't want you to just memorize formulas. You could always derive this. Cool or not cool? So hopefully your SAT scores are improving by the second now. All right, find the perimeter. Keyword perimeter. I like that word. Of a circle with a central angle 7 pi over 4 and a radius of 10. All right, so here's my visual, guys. Here's my visual. So let me draw a circle. And here it is. So 7 pi over 4. So I'm going to start right here. And I'm going to go, there's my center. And I'm going to go right there. So they want to know everything in blue. The radius is 10. That's 10. That's 10. So imagine this is a bird's eye view. So you're a bird, and that's what you're seeing in blue. And while you're flying through the air, because you're enjoying your freedom, you say, I wonder what that length, I know, I'm just making up. I wonder what that length of all that fence is in blue. You guys are entertained. I'm entertained, though. What's 10 plus 10? So that's 20 feet. And now I got to add this arc length in burnt orange. So let's add that burnt orange. Plus that angle, this angle right here, what was it? So according to my arc length formula, I'm just going to go 7 power 4 times 10. See? And then I would just do, what would I do? I would say 2 goes into 4 twice, 2 goes into 10, 5, and then 5 times 7, what's that, 35? So I would go 20 plus 35 pi over 2 feet. And done. That's it. Are you guys okay? What's up?
So how, like, where did it? Like, I know you added 10.
I just reduced it. I just said that's a 4, that's a 10, greatest common factor, and 2. So 2 goes into 4 twice, 2 goes into 10, 5. And now just 5 times 7, so 35. 2 times 1, so 2. You know? That's a fraction, so that's on top, and that's the denominator, so that's on top.
But the 20.
There's a plus in the middle, so you can't multiply it with that. That plus is there.
No, like the number, like in the formula, where it's like 20 feet plus whatever, like where did the 20 come from?
Perimeter. Perimeter means add everything around. add everything around the exterior. Yeah, keep asking questions. So that's 10, that's 10. If that was part of the fence, you're going to go 10 plus 10 plus how much fence do I need? Plus whatever all this is.
Oh.
Yes.
What are the different your different colors mean? Or is it just
The burnt orange is arc length, the blue, everything in blue is what I want, and the red is everything. No, keep asking, keep asking. You doing all right, miss? Okay. I know, guys, I know that this is, but here we go. We're almost done. Find the area of a sector when theta is 135 degrees. Okay, so here we go. Area of a sector. So here's my circle. Here's my circle. And 135 degrees, I'm going to go bam. And 135 degrees is probably like right there somewhere. So there's my 135. And it wants to know the area of this part. So I'm going to go, Chop, what are you going to do? Area equals 135 over 360. This is like a percentage times pi times 6 squared, pi r squared. There it is. This is this question is a very popular SAT question. So there it is. Hopefully it's easy work for you guys. And then I'm just going to go 135 over 360. I'm going to go 135 over 360. 135 over 360. Oh, dang it. 135 over 360 times and I already forgot. 36. Leave the pi alone. Times 36. So turn that into a fraction. There it is. 27 pi over 2. 27 pi over 2, and I need units, square centimeters. How do we feel, guys? Okay. How do you pronounce this? Well, I already told you guys, but do you guys pronounce that as centimeter squared, or you guys go square centimeters? Yeah, it's square centimeters. Let me tell you why, in case you're like, job. Oh man, we don't have square tiles. Okay, we got square tiles up there. So when you go to Home Depot, do you guys go to Home Depot? Do you guys like going to Home Depot? When you go to Home Depot and you're trying to buy all these tiles here, do you go to Home Depot and you say, I need 5 tiles squared? I guess you could. Or or what sounds more correct, quote unquote? Or do you say, oh, I need 5 square tiles? What sounds more correct to you guys? So that's there it is. So that's what you say. You say the square first because that's the shape. That's how, so whenever you say 32 square inches, it's literally a square inch, an inch in the shape of a square, 1 by 1, and 32 of those. So if you pretend, I don't know, that looks like what, maybe like 2 feet or something. So you say 4 square feet, it's, well, that's not 4, but 2 of those, like 4 square tiles. Okay, I know, I'm mixing words. Back in our old room, in the old office, if you look down on the floor, those tiles were perfect squares, 1 foot by 1 foot. So it was so easy to go, oh look, 4 square feet, 1, 2, 3, 4. But look, these tiles are rectangular; they're not even squares. So that goes away. I'm very bad with my. Can you guys understand my English? Because my English is bad. So is my Spanish. I can't speak either language. Can you guys understand what I'm saying right now?
Yes.
Okay. Because I don't know. Okay. How do we feel, guys? Are we okay?
Yes.
All right. Was that a bad example? Did you like the Home Depot example?
No, it's a good example.
Okay. Yeah. Okay. Here we go. Oh, okay. One last question before I get into this. If we represent area in square units, why, when we find area of a circle, why is it still in square units? It's a circle. Tato Quinones. I mean, I know the answer, but I want to know if I'm sure he knows. I guess if you Google, you can find the answer too. But why, when we find, when we find area of anything, it's in squares, right? It's in square units. But why, when we find the area of a circle, why is it still in square units? It's a circle. Do you know what I mean? It's a circle. Why can't? Okay. Here we go. A sector of a circle has a central angle 7 pi over 4 and an area 63 pi over 8 square feet. Find the radius of the circle. Is this in radians? So it's going to make your job so much easier, guys. You're going to come over here to your notes and you're going to say, oh, look, area of a circle, if it's in radians, is theta r squared over 2. Do you guys see that? So you're going to come over here, and you're going to say area equals theta r squared over 2. And this is what that area is. So you're going to go 63 pi over 8 equals square feet. Notice I have to put the square first. Equals 7 pi over 4 times r. We don't know what that r is. All divided by 2. I'm going to do keep, change, flip. So that 2 is going to go where that 4 is. So we're going to write it like this. 63 pi over 8 equals 7 pi over 8 r squared. Are we okay? Okay. Old Chavez used to tell you guys to just, oh look, there's an 8 in the bottom, cancel them out, 63 pi equals 7 pi r squared. But you, Chavez, not that, I've seen the light or anything. I just think you guys see it easier. New Chavez does this. To isolate r squared, you multiply by the reciprocal. So you're going to go times 8 over 7 pi. Whatever you do to 1, you're going to do to the other. 8 over 7 pi. I think that's better for you guys because then, I don't want you guys to become robots. So when you do that, this 8 cancels out. Bam, bam. See? That 8 cancels out. That 7 pi cancels out. So r squared on the right-hand side. So here we go. So get out of here, 7 pi's. Get out of here, 8. And those 8s get out of here. And then I see the pi's. Those get out of there. How many times does 7 go into 63? 9. So I have 9 equals r squared. Look how much neater and clean that was. Was that cool or is that not cool? How do I get rid of that square there? Yeah. You can say plus minus, but we're talking about distances, so you're not going to need the negative part. Does that make sense, guys?
Yeah.
Okay. Last 2. I think this is the last 2. A car has wheels with a 6-inch radius. It's a small car, probably like a golf cart. Golf cart. If each wheel's rate of turn is 5 revolutions per second, find the angular speed in units of radians per second. Start with, we're going to do stoichiometry, dimensional analysis really. 5 revolutions per second. And in 1 revolution, how many radians are there? No, that's degrees. I want radians. 2 pi radians. Revs cancel out. What's 5 times 2 pi? 10 pi. Radians per second. There it is. We will talk about this topic in full details in about a month from now. What's up, Miss Taylor? Ask.
I just don't understand the stoichiometry.
Oh, it's dimensional analysis. You don't have to call it stoic. You see how I have revolution in the top? That's what I want to cancel. So I put 1 revolution on the bottom. And then you just say, how many radians in 1 revolution? So this is kind of like a scale type of thing. In 1 revolution, there's whatever. So in 1 revolution, there's 2 pi radians. Whatever you have on the top, you multiply. If you have something in the bottom, you divide. I have nothing in the bottom, but 1. So 5 times 2 pi divided by 1. So there's 5 times 2. Yeah, keep asking, miss. Keep asking. We're okay? Okay, you're going to like this one because it's pretty much the same. A car has wheels with a 9-inch radius. Okay, so it's a little bigger now. If each wheel's rate of turn is 6 revolutions per second, how fast is the car moving in units of inches per second? Okay, so here we go. I'm going to write 6 revolutions per second. Are you okay right now, Miss Taylor? In 1 revolution, do you agree that 1 revolution is the same thing as saying circumference of a circle, which is 2 pi times r? So in 1 revolution, I cover 2 times pi times whatever those radius is. What's this radius? 9 inches. This is the circumference of a circle. 2 pi r, where r is radius. That really is, of 1 radian, it really is a radian. Okay? Check it out. Revolutions cancel out, and you get inches per second. So let's see if we can do this without a calculator. 6 times 2 is 12. 12 times 9, 99, 108. 108 inches per second. I have to do it in pieces. Oh, yeah. Pi. Yeah, the pi didn't go anywhere. Sorry, miss. Yeah, keep me on my toes, miss, because I make mistakes all the time, especially after lunch.
I just thought you did it in your calculation.
Oh, miss, pi goes forever. It would have had lots of little, yeah. I'm hungry, I'm sleepy, and I want to take a nap. So here's how your quiz is going to look. Do you have, relax. Do you have access to your unit circle from last week? Okay, take it out. Very few people get hundreds on the first attempt. I would not recommend that you try to get 100 because then you're just going to get a lot of anxiety, guys. I'm telling you, the first 3 are not going to count. So the first quiz, you should not have any anxiety. I will post a practice on Canvas. If you want to pick up a copy, swing by tomorrow and I'll have copies for you that are practice copies. All right. So on your unit circle, you do not have a negative pi over 3 because all those angles are positive. They're all going counterclockwise. So let me give you a visual. Negative pi over 3, well, I guess first let's do positive. Positive pi over 3, I would have gone like this, and there it is. So that coordinate should have been 1/2 comma square root of 3 over 2. But I want to rotate the same amount, but I want to go clockwise because it's negative. So here I am. This is the one in red. I'm rotating clockwise the same amount, but negative because I'm going clockwise. So that half is still positive, negative square root of 3 over 2. So sine, what did we say sine was? X or y coordinate? The y coordinate. What's the y coordinate of negative pi over 3? Now, I don't want you guys to be a robot. Do you remember why sine was the y and why cosine was the x? No? Okay. Really fast. Let's see. Do we have space? Okay, I think we have space here. So here's my unit circle. And if I were to, remember that the radius of a unit circle is 1. So this coordinate here is x comma y. So my horizontal displacement here is x. My vertical displacement here is y. Do you guys agree? So Katoa, look at all the constants that we're putting together. So if I said sine, here's my angle. If I said sine of that angle, you're going to tell me y divided by 1, which is just y, see? If I told you cosine of that angle, remember that hypotenuse is 1. It's going to be adjacent over hypotenuse, so x divided by 1, which is just x. And if I tell you tangent of that angle is going to be y over x. Cool or not cool? Cool. Now, if I tell you secant of that angle, secant's a reciprocal of cosine, so it's just 1 over x. 1 over x just means reciprocal. So here we go. Ready? Sine of negative 5 pi over 6. Okay. 5 pi over 6 would have been right here in quadrant 2. That would have been a negative square root of 3 over 2. That would have been a positive 1/2. But I don't want 5 pi over 6. I want negative 5 pi over 6. So I am going like this. You rotate the same amount, but you're right there. So look at your unit circle, and negative 5 pi over 6 is the same as 7 pi over 6. What is sine of negative 5 pi over 6? There you go, negative 1/2. Cosine of 3 pi over 2, negative y-axis. So go to 3 pi over 2 and look, cosine is what? The x? What's the x value? Not everyone at the same time. 0, guys. 0, yeah, 0. It is a safe space, guys, so it's okay if we get it wrong. It is a safe space, I promise. I hope you don't have those teachers that tell you like, no, that's wrong, blah, blah, blah. Like, guys, it's okay. It's chill. Like, if you get it wrong, it's not a big deal. That's how we learn. All right, secant of 5 pi over 6. Job, I don't know how to do secant. It's not in my unit circle. It is, go to 5 pi over 6 in quadrant 2. And secant is the reciprocal of cosine. I don't say anything about rationalizing, so you don't have to rationalize it. Just give me the reciprocal. So what's the reciprocal of cosine? Cosine of 5 pi over 6 is, you want the x coordinate. So negative square root of 3 over 2, right? So take the reciprocal of that. It's going to be? Yeah, you can just say negative in the front. And 2 over square root of 3. You do not have to rationalize it. You can if you want. Negative 2 square root of 3 over 3. But you can leave it like that as well. Cool or not cool? Okay. Tangent of 11 pi over 6. Okay, let me do the unit circle for you guys on this one. 11 pi over 6 is right here, really close to 2 pi. And that coordinate is square root of 3 over 2, comma, negative 1/2. So it's tan is y divided by x. So negative 1/2 divided by square root of 3 over 2. The 2's cancel out, and you just get negative 1 over square root of 3. You can rationalize it if you want, but that's okay right there. Are we okay so far, guys?
Yes.
Okay. Tangent of pi over 3. So here's pi over 3. Remember that coordinate is 1/2, comma, square root of 3 over 2. You're going to go y divided by x. Square root of 3 over 2 divided by half. The 2's canceled out. You just have square root of 3. We're still okay, guys? Cosine of 2 pi. Or negative 2 pi. Well, it's the same. Cosine of 2 pi and cosine of negative 2 pi is the same. Negative 2 pi is right here. What's that coordinate? What's the cosine? No, not 0, 0. Yeah, 1, 0, but give me just the x coordinate. What is it? 1. Do you guys see how we're doing it? Okay. Cosecant of 11 pi over 6. Cosecant is the reciprocal of sine. So go to sine of 11 pi over 6. Sine of 11 pi over 6 would have been a negative half. So cosecant has to be a negative 2 over 1, which is just negative 2. Do you see how we're doing it, guys? Okay. Cosine of 3 pi over 4. Go to quadrant 2. Negative square root of 2 over 2. Still okay? Degrees. Well, probably hit you with just radians, but you should know the degrees as well. Sine of negative 30 degrees. Negative 1/2. Cotangent of 120. Child, I don't know that one. Okay. Go to 120. There's 120. X is negative half. Y is square root of 3 over 2. So cotangent is x over y. So negative 1/2 over square root of 3 over 2. So negative 1 over square root of 3. Do you guys see how we're doing it? Cosine of 150, sorry. So go to 150 degrees. And the cosine is the x coordinate. So negative. Perfect. Sine of 300 degrees. So that's in quadrant 4. And it's a y value. Negative square root of 3 over 2. Sine of 270 degrees. Negative 1. And tan of 315 degrees. They're both the same magnitude. One's positive, one's negative, so negative 1. At first, they're pretty tough. Remember what I told you last week, guys. Don't memorize each element at a time. Do it with grouping. Like, know your all the pi over 4s, all of them in the unit circle. All the ones that are pi over 4, all the coordinates are square root of 2 over 2. You just got to figure out whether it's negative or positive. In quadrant 1, they're both positive. In quadrant 2, the x is negative. In quadrant 3, they're both negative. In quadrant 4, the y is negative. Does that make sense, guys? So yeah, so just make sure to when you use your big brain, big guy. Yeah, that was dumb. I won't do that again. I'm just remembered some song there. Big guy, big guy. Okay. Anyways, whenever you categorize, put it in groups, guys. Use your brain efficiently. You're smart. All right, guys. Take care of the delta. We're done, and hopefully you guys had a good learning experience.
So this is what the test is gonna look like, Mr. Sean?
The quiz.
I mean, the quiz.
Yes. You're good, miss. You're good.